Hey there, chemistry students. This is Ms. Ruark. We're in vodcast 3.3 and we're going to learn how to name covalent compounds in this vodcast. Whoop whoop. All right, so what is a covalent bond? We've talked about this. A covalent bond is a bond where atoms are sharing one or more electrons with each other to form the bond. Okay, we've already talked about ionic compounds. We've done a whole lot of work with ionic compounds. You need to remember the rules for naming an ionic compound and for writing the formula for an ionic compound because they're different. Why do I keep stressing this? Because it's important. Okay, so remember, ionic means that it has a metal bonded with a non-metal. It also means that it has ions in it. So it could be a polyatomic ion. First, ammonia, right? So it's a positive ion with a negative ion. And remember that we take those and we cross them to write the formulas. Our charges have to cancel. And it has to be an overall charge of 0. And if it's a transition metal, we use Roman numerals to show the charge. Right? I'm just reviewing. That's all I'm doing. This should not be new. Okay, I'm just reviewing with you. Okay, let's move on. So, covalent compounds. They are different. We name them differently because they are different. We have to show their difference. Okay, so atoms here, they share electrons. Here, they transfer electrons. That's how you get your charges. All right, when they share electrons, they share them so that each atom is left with a full outer shell or valence electron shell. So they're happy, just like the noble gases. And remember that a covalent bond forms between two nonmetals or more. Two or more nonmetals. All right, so examples here. Remember when we did those dot structures and the dot shows how many valence electrons there are? Well, if we have hydrogen bonding with hydrogen, one hydrogen has one dot because it has one valence electron. Well, what if we have two hydrogens? Well, we would have a hydrogen with a dot and we'd have two of those, right? Each of those needs an electron to make them happy. Now, they can't go out and just steal somebody's electron. I mean, I guess they could, but it's just really unethical to go around stealing people's things, right? They don't want to get thrown in jail. So this hydrogen's walking around, sees his buddy. He says, hey, yo, you need an electron. And the other hydrogen says, yeah, I need one. You need one too? He's like, yeah, I do. So they're like, well, hey, how about if we share? I know, you guys are like, share? We don't share. Oh my gosh. Yeah, it's a nice thing to do. So let's share that electron with each other. Okay, so those two end up sharing electrons between the two of them, and we'll write the formula as H2. Oh. Okay, so what if we had hydrogen and oxygen? All right, well, hydrogen's here chilling on the corner looking for an electron, right? Here comes oxygen. And oxygen has how many valence electrons? It has 6. All right, oxygen needs a valence electron to fill up this and a valence electron to fill up that. It needs 2 to be happy. Well, hydrogen's here and it says, hey, oxygen, you want to share an electron, make me happy? And oxygen's like, well, that's cool and all, but like I still need another electron. And like, so you need to call your buddy up and tell him to come over here and share another electron with me. So that way we're all happy. And so I know you guys love my voices. So hydrogen calls his buddy. They end up sharing. And that's how we end up making water. We've got hydrogen sharing an electron, hydrogen sharing an electron, and they're all happy. Yay, happy day. All right, what about chlorine? So chlorine's a pretty nasty little booger. It only needs one electron to make itself happy, right? And it can't find anybody. But it sees its twin chlorine across the street. And it's like, yo, chlorine, why don't you come over here and share your electron with me so I don't beat nobody up? And so chlorine comes over and says, all right, fine, we share an electron. And so they both share an electron, and they're both happy because they're not going to go beat anybody up because, you know, that would be bad and they'd end up in jail, and we don't want them to be in jail, right? This is easy stuff, I know. All right. Well, what about oxygen? If we had 2 oxygens, well, oxygen, remember, each has 6 valence electrons. So we have 2 oxygens here, and each one has 6 valence electrons. Well, they decide to share. And they share right there. They're going to share these. Okay, so now oxygen, but they're sharing 2 sets of electrons. They sure are. And that's what we call a double bond. We'll get into double bonds when we get into Lewis structures in a couple of vodcasts. So they're sharing there to give us O2. All right, well, what if we had carbon and 2 oxygens? Well, remember, Carbon makes or has 4 valence electrons. Oxygen, we just did this, has 6. So oxygen will share right here. Okay, well, we've got another oxygen over here, and this one says, hey, I need some electrons, so I want to share. And so they end up sharing. So carbon is sharing a whole lot of electrons with each one of these oxygens, and that would be 2 sets of double bonds. Okay? Just to give you an idea, this is a precursor into what they look like. And then you can try number 6 on your own, but I'm going to keep moving. All right, so how do we name these things? Well, we use the IDE ending. Remember, we got still changing to IDE, but each element has a prefix. What do you mean by a prefix, Mr. Ark? Here you go. You can have 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, blah, 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 blah. The only one that seems to confuse everybody the most is this one. I'm not sure why. That's all right, just memorize it. Okay, so remember, when we name an ionic compound, we use Roman numerals, right? And the Roman numerals, we only use them with transition metals. TM stands for transition metals, and it shows the charge. And it's the charge, yes, I'm reviewing, charge on the metal. So if you didn't know that, shame on you. All right, well here, the prefix refers to the number of atoms, not the charge. Okay, and we use prefixes on every single element or every single atom except we drop mono for the first element. So on the first element, you'll use di, tri, tetra, penta, hexa, hepta, octa, nona, deca. On the second element, you'll use every single one of them. The only time you drop a prefix is if it's mono for the first element. Don't drop them for anything else. All right, and then we also drop the first vowel, so the vowel's here, to avoid vowel confusion. So if there's a combination of OO or if there's a combination of AO, we will drop that first, the first vowel, so that it doesn't confuse. Okay, so what does that mean? Ooh, that was loud. All right, so here we have 1 carbon and we have 1 oxygen. Okay, so your first inclination would be to write monocarbon, monoxide. Okay, so if you wrote that, it's okay. All right, so now we're going to come here and we say, oh, look, you can't write mono for the first element, so we've got to take the mono off of the first element. Oh, and look, if there's a vowel confusion, you have to drop the first vowel. Okay, so we would rewrite this as carbon monoxide. Oh, that's easy. That's right. Okay, so do those steps every time. Don't skip steps. Don't be a cheater. You're going to get it wrong if you do. I don't want you to get it wrong. I want you to succeed. Okay, so make sure that you follow those steps. All right, so the next one, we have 4 phosphorus and we have 10 oxygen. So your first guess would be to write tetra, 4, phosphorus, because it's phosphorus, deca for 10, and then oxide, because it's oxygen. All right, now, let me get my red. There we go. Okay, drop mono for the first element. Nope, don't have to worry about that. First vowel is often dropped to avoid combination of, yep, we got to drop that. Drop that one right there. Okay, so now we would rewrite this as tetra, phosphorus, decoxide. Oh, I got this. It's so good. Okay, let's do one more, and then I'm going to give you 3 to practice on your own. All right, 1 S and 2 O's. So we would write mono, sulfur, and I know you're like, Miss Rowe, you're going to do that. I'm just going step by step. If you've got this already, you do this, okay? And then check your work with me in just a second. All right, so monosulfur dioxide. Let's go back and check our rules though. Can we write mono for the first element? Nope, take that off. All right, dioxide, is there vowel confusion? No, there's not. So it would be sulfur dioxide. Piece of cake. Okay, I want you to pause it. I want you to try these 3, and then I want you to come back and check your work. Pause it. I said pause it. Okay, hopefully you got those answers. Carbon tetrachloride, diphosphorus trioxide, and iodine heptafluoride. If you didn't, star them. Ask me about them in class. Okay, writing formulas from names. So how do we write the formulas from the names? Well, first we have to identify the elements involved in the compound. And then we're going to use subscripts to write our formula. How do we know what subscripts to write? We get those from the prefixes, because remember the prefixes tell us how many atoms, and the subscripts tell us how many atoms. It's the same thing. All right, so examples here. We have nitrogen dioxide. So what are the elements involved? We have nitrogen and we have oxygen. How many nitrogens here? Well, it doesn't say anything, so we must have 1. How many oxygens here? We must have 2, because it's di. Okay, so we write it as N1O2. Do we write ones? No. So we take that out, NO2. Oh, that's so easy, Miss Ruark. I know it is. Okay, dinitrogen trioxide. We have nitrogens and we have oxygens again. Oh, look at there. It must be the same thing, right? No, because it says dinitrogen, which means you have 2. And it says trioxide, which means you have 3. And so we would write it as N2O3. Can I take out anything? No. All right, so look, it's not the same thing. It's 2 completely different compounds. They behave completely different. They have different characteristics. Okay, phosphorus, tetraphosphorus decoxide. So in this one we have phosphorus and we have oxygen again. Oxygen's a famous one. It's very famous on the periodic table. It's used in many compounds. Okay, tetra means 4 and deca or dec means 10. They took the A off because of vowel confusion. So this would be P4O10. Okay, now somebody's probably like, hold up, wait a minute, you can simplify. No, you never, ever, never simplify covalent compounds. Never. Never. Okay, don't ever simplify them. Ionic, you better simplify it. Covalent, don't do it. All right, and then on the last one, we have xenon tetrafluoride. So we have xenon, and then we have fluorine. All right, how many xenons? We have 1. How many fluorines? We have 4. So we write this as XeF4. And that should be good to go. All right, last thing that we need to worry about is when you are naming and writing formulas for compounds, you have to figure out if it's ionic, acidic, or covalent before you do anything. Remember, if it's ionic, it's going to have a metal first, or it'll have ammonium first. Okay? If it's acidic, it'll have hydrogen first. And if it's covalent, it'll have a non-metal first. You have to decide that, because if you don't, you're going to get it wrong. Okay, so how do I know that? Well, Fe2O3, you'd look at this and say, oh, well, that's got to be di-iron trioxide, because we were just talking about covalent compounds. Wrong. Why? Because that is a metal. How do I know? Because it's on the metal side of the periodic table. Because I'm a good student and I have my periodic table in front of me right now. Busted. Okay, and it's iron. Iron is a metal. All right, so we would write this as iron 3 oxide, and I told you I wasn't going to make you learn those, so I'm not going to put that in there. But we would name this as iron 3 oxide. How do we know it's iron 3? Well, because oxygen has a -2 charge, which gives us an overall charge here of -6. We need to cancel that out. If I have 2 of them, what times 2 gives me a +6? A +3. Why do we have to use the Roman numerals? Because it's a transition metal. These are all things that you should know, and if you don't, oh, I'm sorry. We need to go back to work in school, okay? Okay, so when you come into school, if you still don't get all that right there, make sure you come see me. All right, on this last one, it says memorize this. If we were to use the regular naming for this, we would say that, ooh, this is a covalent compound. It would be, I'm not even going to go through the steps. It would be nitrogen trihydride. Okay, and if you said that, yeah, you're not wrong. But we call this by its common name, which is ammonia. So just memorize that, okay? Just like H2O, do we call it dihydrogen monoxide? No, we call it water. It's just its common name. That's all. All right, I think that's it, ladies and gentlemen. I will see you in class.